Today we're going to talk about DEA, Data and Development Analysis. DEA compares the relative efficiency of organizational units such as DMUs and prepares these units to utilize similar resources that are inputs and outputs and generate an efficiency valuation. For example, a shop has inputs of staff and floor space and has outputs of sales and volumes and total revenue. However, there can be considerable differences in the way in which individual units combine its inputs to produce outputs. In addition, there may be also differences in potential among units caused by technology they have available, their geographical location, population. So the DEA allows you to take into account all of those factors that affect the performing units, the DMUs, and provide them a complete comprehensive assessment of their efficiency. It does this by converting multiple inputs and outputs into a single measurement of product efficiency as you evaluate particular DMUs in comparison to other DMUs. By doing so, it identifies those units which are operating relatively efficient and those which are not. The efficient units, those making best use of resources, are rated at being 100% efficient, whilst the inefficient ones obtain a lower score. What we have before us is a DEA project that we're going to look at, and the objective is to evaluate the efficiency of outsourcing scenarios within electronic manufacturing industry. So what you see here is input measurements of staff, research, cost, quality, cost, the decision-making units, which is internal, which would be domestic to the US, China, India, and Brazil. You have output measurements for these DMUs to take into effect, and that's the time to market in days, the brand recognition, which is evaluated on a scale of 1 to 10, volume in the millions, and profits in the millions. So our conclusion, we're going to be applying a weighted average to the DMU's output, which will evaluate the efficiency of each decision in comparison to the others and allow for feedback in the improvement of the DMUs that are less efficient. So what we're going to look at here is this is a program that we put together in Excel, and basically you saw the same type of information that was input here. Now, one of the nice things about this is that if we click on this, you will see up at the top in the function category that the inputs, this is coming from a different tab, basically. So whenever you see equal and some kind of identification with an exclamation mark, that means that it's on a different tab. So this input in this particular worksheet on B5 should relate to an input on a location of H3 on the input tab. So let's go to the input tab here. On the input tab, we go over to H and 3. It looks like H3 shows a 35 value. And if we go back to this, yes, we have a 35 value. Now what this allows you to do is the inputs you can break down into a bunch of different categories. So instead of trying to make the page very convoluted and have all kinds of different information, it's easier for the particular business units. In this case, we have engineering, management, quality, procurement, and sales, to effectively put in their staffing breakdown for each one of these categories, and thus gives us a total category, which is what we've placed in H3, and what is pertinent to the input of staff needed for for the internal, which is 35. Now we've done this throughout the entire DMUs. So China has the same exact thing. If you look at China here, for instance, it's an H4 on the input category, and if you go to H4, we have a 27, which relates to the same value we have here. So I've went ahead and did this for the entire area of inputs and output measurements, and just so that you can see here, I have the output tab, and within the output tab we have all of these categories. Okay, down below here you will see that the simple calculation or simple function of the sum product of time to market, which is all of these values here in B11 all the way through E11, and those are compared to or sum product with the efficiency numbers here in B21 through E21, and F21 being your efficiency value. So if you go to your data tab and you run your solver here, you will see our targeted cell is this minimum efficiency value that you see here in J23. The changing cells are all these efficiency numbers here because they're going to change based on the category or the DMU that you're effectively looking at. In doing so, you want your sum to be 1 being efficient or 100% being efficient, and you want to have your functionalities of your B25 through B28, which is these values here for your outputs, and you want to compare them to D25 through D28, which is your calculated values that are going to go in, or your values of input per what you're going to evaluate. In this particular case, we are let me go back there. In this particular case, we are evaluating the E section. So E11 is going to be the output 11. So we're looking at Brazil as far as efficiency is concerned in this particular one. If you wanted to look at, say, China, then you would put in C11 here instead. So let's go back to our solver. Then you want your functionalities here as far as outputs to be greater than your sum product, because of the fact that the better outputs you have, the better your company is. Now, inversely to that, you look at your inputs as those numbers being less than, the less that you need to input and the greater your value output would be your highest functionality as far as a company is concerned. So if we solve for this, what you see is it found a solution. I had already went through this just to check it, and what it's showing here is that Brazil is 92% efficient. So it shows a zero function right here showing that it's 92% efficient. If you were to run this, if we were to change these values to B, and we're going to do that now, so let's change it to B. Enter. Let's go ahead and change all those to B, and since these are multiplied by the efficiency numbers because they are the inputs, we're going to change those to all the B values up above. And in doing so, let's set these up here. In doing so, we will go back and we'll run the solver one more time and see what we get as far as the United States and efficiency is concerned. And it says it found a solution. So now, as you can see right here in, let's hit OK here. As you see in B21, international is 100% efficient in comparison to the rest, which would be 0. So it looks as though the efficiency number that you get, because we have the places after the decimal point brought out, the efficiency number you get is 112% efficient compared to everyone else. Now what happens is you end up doing this individually for each particular one. So I'm going to show you one that I did with Professor Pardee, and let's see if we can find that one. Here we go. What we did is I worked on is simply inputs and outputs with multiple DM units, and basically what we came up with was a tab for each individual group. So here's the optimization if you were to optimize just for WG, and WG happens to be this particular efficiency number shown in H20, and WF, of course, you highlight it. It looks like WF was very efficient. Now the one that we found that was inefficient, I believe, was WD. Yes, here you go. So the solution for WD was 92%. So WD was not efficient. And as you looked in some of their binding categories, you will see, and you take some time to evaluate this, but you'll see over here you have allowable increases and allowable decreases. And what you'll find is the values that are in this RH column here, if you were to adjust the values up top to these values, you would find an efficiency for WD that would be 100% with everybody else. Now, one of the other things that you'll find is that you can do multiple inputs, multiple outputs, and multiple DMUs, as I'm showing here. Now, to make something very simple, you could buy the software from Banksia, and Banksia has contributed a lot to this particular presentation, but as you can see in this area right here, you can run their software and it would tell you all the DMUs that are efficient and all the ones that aren't efficient and what their efficiency numbers are. Hopefully that helps in your process in looking at DEA, and I thank you for listening.